So the problem we're tasked with today is finding the longest substring without repeating characters inside of a string. This is number 3 on Leetcode, and it's considered a medium difficulty problem. And we're given a string S, and we need to find the longest substring where we don't repeat characters. So as an example of this, we have ABC, ABC, BB. Our answer for the longest substring would be ABC because each of the characters in here is present at most one time. Now, if you wanted to do this in sort of a brute force solution, you would try to generate every possible substring, but this is not a good way to do it. If you think about it, we are just working with a sliding window, right? We're trying to find a maximum substring where none of the characters are repeating. So that's our first hint. We're going to be using a sliding window, and we need an efficient way to store whether or not we have seen a character before. So you might want to think of using something like a hash table, because hash tables are very efficient for lookups. So let's go over to the sketchpad here and work out a solution. If I want to have a sliding window, then that usually means I'm going to have a left pointer and a right pointer, where the right pointer is ahead of the left pointer. So I'm going to initialize at the start. My left pointer is here, my right pointer is also at the start. What I need to do is check if I've already seen this character before. If I have, then I'm going to need to adjust my sliding window accordingly. But right now I've only seen 1D, so I would store in my dictionary or my hash table 1 for D. I can move my right pointer over 1, so let's put left here and let's put right here now. I have not seen E before, so E would also get 1 inside of my hash table. Right pointer would move over to F, would also be 1, and so on and so forth for A, B, and C. So my right pointer is now going to be over here. Now the tricky part gets to be when I see a duplicate character. So right pointer is now going to move over to A. I already have an A present inside of this string, right? So the count I would have for it would be 2. Well, this would actually not be a valid substring for us to return in this case, because I have 2 characters right now that are the same. So the longest substring that doesn't have any repeating characters would be immediately before this, and that would be 6, right? So what do I have to do? I need to shift my sliding window over from the left now until I've corrected this error where I have more than one A. So that means that I would have to move my left pointer all the way over past this A in order for A to go back down to 1, right? So during that time, I will be getting rid of my D, getting rid of my E, getting rid of my F, and then finally getting rid of my A. So I would have left and then right, and this would be a difference of 3, right? We have B, C, and A. That would just be 3. So obviously, we would need to keep track of the 6 so that we return the longest possible substring. But we're going to follow this exact principle in code now. So the first thing we're going to do is check and see if we even have the string, because in the preamble here, it says that our string could be of length 0. So if not S, return 0, because obviously you can't have a substring longer than 0 if you don't have a string. I'm going to keep track of an answer that I'm just going to continually update as I find a longer substring. And then I'm going to make a hash table. Now I'm going to be using the default dict from collections. And the reason why is just because it's almost identical to a regular Python dictionary, except you won't get an error if you index into it and you've never seen that particular key before. Instead, if you've never seen that key before, it'll just initialize it as whatever you set it to. So I'm going to set hash table is equal to default dict, and it's going to be an integer. So that means that if I initialize with a new key, it's going to be set to 0. Then what I'm going to do is set my left pointer, and that's going to start at 0. Then I'm going to iterate through every character in my string exactly 1 time. So for my right pointer and my character in enumerate, then S, what am I going to do? Well, I'm now staring at a new character, so I need to add that to my dictionary. So ht of C plus equals 1. And again, if I have not seen this key before, when I index into it, it will automatically set it to 0 because that's what I've set to as an integer right here. Here's the thing though, what if we end up with, again, something like A is equal to 2? Well, we now need to move our left pointer over and we need to remove the elements that we are passing now with our left pointer from our dictionary. Okay, so while ht of our character that we're currently looking at is greater than 1, so if we've only seen a character one time, we're not going to go into this loop. But otherwise, what we're going to do is go to where our left pointer is in our string and get that character, and then check our hash table, and we're going to remove one value from it. So that's exactly what's going to happen here. I start at left pointer. Okay, I'm going to go into my string. I'm going to get D. Then I'm going to go into my hash table and decrement my 1 to 0. I'm going to start repeating this process for D, E, F until I hit A, and then I'll have B, C, A left over. Okay, then I'm going to increment my left pointer. And once this is done, what I'm left with is a sliding window that will only have unique characters in between it. So what I'm going to do now is check my answer by going answer is equal to max of whatever I have previously stored here, and then my right pointer minus my left pointer plus 1. And then I'm going to return answer. Now, what's the time complexity for this? Well, I'm only going to be touching each of my elements one time, so therefore my time complexity would be linear. What is my space complexity? Okay, it should also be linear, because in the worst case, I'm going to be storing every possible element inside of my string into my hash table. So again, it should be linear. So let's try, I got to have return answer, there we go. Let's try running this. We've passed all of our test cases, so let's submit. And we have solved the problem. Thank you.